Hello students and welcome to today's class. I am Dr. Neeti Rathore and I am back with another video lecture on IUPAC Nomenclature of Organic Compounds. In part 1, we discussed the aliphatic hydrocarbons, straight and branch chain without functional groups. In today's class, we will discuss aliphatic hydrocarbons with functional groups. So I would expect you all to take a paper and a copy and pen and practice along. Then only you will understand the whole thing. So now we are taking aliphatic hydrocarbons. Aliphatic hydrocarbons are organic compounds with functional groups. Aliphatic hydrocarbons or aliphatic organic compounds with functional group. Now the name of an organic compound with functional group is composed of 4 different parts. Listen this very carefully. 4 parts. The first part is a prefix. Second is primary suffix. Third part is secondary suffix. And one more part we have that I will tell you later. Firstly, what is a prefix? Prefix is decided by the word root. And word root is in turn decided by number of carbon atoms. Yes, we know like eth, meth, prop, but and so on. Hept, hex, oct, non, dec, like that. Okay. So prefix is decided by the word root, which is again decided by the number of carbon atoms present in the longest chain. Clear? Now, then comes the primary suffix. Now, what is a primary suffix? Primary suffix is decided by the multiple bonds present in the longest carbon chain. Whether there are double bonds present, triple bonds present. So, primary suffix will be in or ein. One of the two. Primary suffix will be in or ein. Now, secondary suffix, the third part of the name, is decided by the functional group. Yes, functional group, whether alcoholic group is present, carboxylic group is present, amino group, or any other functional group. For example, if alcoholic group is there, OH, then all is the secondary suffix, all. In case of aldehyde, al of aldehyde, aldehyde, al of aldehyde is the secondary suffix, and so on. Clear? Now the fourth case is when halo group or a halogen atom or alkyl group is present, then they are taken as the prefix always. For example, halogen means chlorine, fluorine, bromine, iodine. So the prefix becomes halo. Halo is the prefix, that means chloro, fluoro, bromo, and iodo. Right? Are you getting the point? So, in this case, the prefix becomes halo, chloro, fromo, bromo, iodo. Or, if there is an alkyl group present, then it becomes the suffix prefix like you already know methyl, ethyl, propyl, etc. Clear? So, this is how a number of the name of the aliphatic hydrocarbon with functional group is written. Clear? It should have these 4 parts. Clear? Now, let's quickly discuss all the functional groups and the suffixes used for them. We have already discussed all the functional groups in class 10. Let's just do a revision. The first functional group is alkanes, you already know. When there's a single bond between carbon-carbon double bond, then the hydrocarbons are known as alkenes, and the suffix used is ane, we know. Then in alkenes are those in which there is a double bond between carbon and carbon, and the suffix used here is ene. Then in alkynes, we have a triple bond between carbon-carbon, and the suffix used is ine. Similarly, there are arenes. Arenes are aromatic compounds. Basically, they are benzene derivatives. Then we have halide group. In this, you can have any halogen group, halogen atom. It is represented by X, and they are actually used as a prefix. And the prefix used is halo. Halo, for example, suppose there's a chlorine, so we will use chloro. Similarly, bromo, iodo, fluoro, etc. So this is used as a prefix before the name of the compound. For example, 1-bromobutane. Then we have alcohols. The functional group is OH, and if they are used as a prefix, then the prefix is hydroxy. The prefix that we use is hydroxy, and mostly if they are used as a suffix, then the suffix is all. Okay, so you can remember it like this, that the suffix all comes from alcohol. The all of alcohol is the suffix used. For example, butanol, propanol, methanol, and so on. Then next we have aldehydes. The functional group of aldehyde is CHO. Then when they are used as a prefix, then the prefix formyl or oxo is used. And if they are used as a suffix, then the suffix is al. Now you can remember it very easily. The aldehyde, the al of aldehyde, al is taken as a suffix. For example, butanol. You can see in the example given, butanol, propanol, methanol, etc. Then we have another class of compounds which are ketones, and we already know ketones group is carbon double bond O, and this carbon double bond O is basically surrounded from both the sides by a carbon atom. Clear? So that's the difference between the aldehyde and a ketone. Now here the prefix is used as oxo, and when suffix is used, then it is one. So again you can remember it very easily. One of ketone, right? One means O-N-E. One of ketone is taken as a suffix. For example, butanone. And we already know that we will mention the position of the ketonic group. Therefore, in this example, it is given butane to one. Clear? Then, in case of nitriles, the group is carbon triple bond nitrogen. And when used as a prefix, it is used as cyano word is used. Otherwise, when it is used as a suffix, the suffix is used nitrile. For example, pentane nitrile. Clear? Then we have ethers. Ethers you already know are OR. There is oxygen atom surrounded from both the sides by alkyl group. So basically COC, you can call it like that also. Then this is always used as a prefix alkoxy. And the example is alkoxyethane. Then next we have carboxylic acid. The functional group is COOH. We already know that. And whenever it is used as a prefix, the prefix carboxy is used. Mostly it is used as a suffix, and the suffix used is oic acid. Oic acid, for example, butanoic acid, ethanoic acid, and so on. Now we have one more. Suppose we have a carboxylate ion. Carboxylate ion group is basically COO negative. Basically, when a hydrogen from hydroxyl group is taken out, then the molecule that is left behind is carboxylate ion. And here the suffix used is O8. For example, sodium butanoate. Clear? Then next class of compound is esters. And we know COOR are esters. Basically, COO group is ester group. Then the name written is alkoxycarbonyl. The suffix used is OH. Then next group is acyl halides, which are written as COX. Now, acyl halides, in this COX, the X is, of course, the halide group. It can be fluorine, chlorine, bromine, or iodine. The prefix used is halocarbonyl, or when they are used as a suffix, the suffix is oil halide. For example, butanoyl chloride. Then we have amines. Amines you already know is NH2 group is known as amine. If it is used as a prefix, then the prefix amino is used. And when it is used as a suffix used is amine. For example, butan, amine. Then we have amides. Amides we already know is CONH2 group. They are basically condensation products of what? Amino group and carboxylic acid. This we have discussed in polymers also. Then when they are used as a prefix, the prefix carbamoyl is used, and then they are used as a suffix. The suffix used is amide. For example, butanamide. Then we have nitro compounds. Nitro group is NO2 group, and they are used always as a prefix. The prefix is nitro. For example, 1-nitrobutane, 2-nitropentane, and so on. Then last group that we will talk about today is sulfonic acids. The group is functional group is denoted by SO3H. Whenever they are used as a prefix, they are used as sulfo. Otherwise, they are used as a suffix sulfonic acid. For example, methyl sulfonic acid. So these are all the functional groups that we are going to discuss in nomenclature. So let's begin. Now on the table that we just discussed a while ago, on that basis, let's take the first example of a hydrocarbon with a functional group. Now this is a hydrocarbon. This is a compound, organic compound with functional group. How will you name this compound? See, there are only two carbon atoms. Now whether you write it like this, one or two, it is one and the same thing. Why? Because both the carbon atom has a hydroxyl group. Clear? And there are only two carbon atoms. So it is very simple to write the name of this compound. How will you write? Since there are only two carbon atoms, so the word root will be it, right? The name will be ethane. I told you, what did I told you? That the prefix is decided by the word root, right? So the word root is ethane. I am not writing the E. It is ethane 1, 2, diol. Ethane 1, 2, diol. So 1 and 2 both has hydroxyl group. There are two groups. Therefore diol. Ol is the suffix for hydroxyl group, alcoholic group OH. OH alcoholic group suffix used is ol. Alcohol. All of alcohol. Clear? Is taken as the suffix. So it is so easy. If I am saying ethane diol, propanol, butanol, methanol, so it is very easy to find, to identify that it is an alcohol, right? So why I haven't written it as ethane? Why E? Because in that case it is basically an alkane. But this compound is not an alkane. This compound is an alcohol. So whenever the compound is not an alcohol, in that case E is dropped. Clear? So it is ethane diol. Okay, I will pronounce it as ethane 1,2-diol, but E is not written while writing the name. Is that clear to everyone? So this is our first example. Let's take one more example. Second example, let's take CH3, CH2, CHOH, CH2, CH2, CH, CH3, CH2CH3, CH2CH3, 3, 3, 6, 1, 2, 8 carbon atoms. Now this is an organic compound containing hydroxyl group and a methyl group as the substituents. How will you name this compound? The first step is to identify the longest carbon chain. So this carbon chain is of 1, 2, 3, 4, 5, 6, 7, 8. This is our longest carbon chain. Now let's number it from left to right. 1, 2, 3, 4, 5, 6, 7, 8. Suppose we are numbering it from left to right, the alcohol group is getting third position and methyl group is getting sixth position. Now suppose we number it from right to left. 1, 2, 3, 4, 5, 6, 7, 8. In this case, the functional group is getting position 6. Now the rule is the priority is given to the functional group always. Whenever alkyl group is there and functional group both are present, the priority is given only to the functional group. Clear? This means that the numbering of this compound should be in such a way that the hydroxyl group gets the lowest number. So the rule is the carbon containing this hydroxyl group should get the lowest number while numbering. So this is the correct sequence which we will follow. So let's strike out the second one. Now let's write the name of this compound. The name of this compound will be, how will you write? Since it is an alcohol, this compound is an alcohol. Why? Because it contains an alcoholic group. So the suffix here will come all. All will be the suffix. Right? The word root is, there are 8 carbons, octane, octane. Alcohol is at 3 position. Octane, 3, all, and 6 methyl. Substituent is written as a prefix before the name of this alcohol. Okay. So now in this case, remember octane is the prefix and all is the secondary suffix and methyl is the substituent which is to be mentioned before the prefix. Suppose an organic compound contains more than one functional group. Then how will you decide the priority order? How will you name that compound? Let's see. Let's discuss. Suppose we have a compound like this. Suppose we have this compound. Now this compound has multiple functional groups. How? It has a hydroxyl group and a ketonic group. Is it so? Try to identify. Now in this case, you need not get confused. Why? Because this is a carbon atom. COOH. This is carboxylic acid group. COH and not alcoholic group. Sometimes you people get confused. You think this is ketone or aldehyde and this is alcohol. No. This is COOH because carboxylic group is written like this also. Clear? So basically this is a carboxylic acid group and this is a double bond. Clear? So in this case, to which group will you give the priority? This is an alkene also. This is a carboxylic acid also. So to decide to which compound the priority should be given, we should know the priority order. Yes, there is a priority order which we all should know. So whenever a compound contains more than one functional group, the compound is known as a polyfunctional compound. Clear? Whenever an organic compound contains more than one functional group, the compound is known as polyfunctional group. Clear? Now, in this case, while naming, one of the functional group is taken as the primary functional group and then the compound is named accordingly on that basis. So the primary functional group decides the secondary suffix. For example, if carboxylic acid is taken as the primary functional group, the suffix will be oic acid. It will be taken as an acid. Clear? And the other compound will become a substituent group. Clear? Now the question is, how will you decide the priority of the functional group? How will you decide which functional group is to be taken as the primary one? Now in this case, this table will help you. This is the priority order, the priority table. The priority order decreases down the column. Clear? Which means the highest priority is given to carboxylic acid and the lowest is given to alkene, alkyne, halo and nitro compounds, nitro groups. Clear? So the highest priority is given to carboxylic acid group, then to sulfonic acid, then ester, then acyl halide, then the priority is given to amide, then nitrile, then aldehyde, then ketone, then alcohol, then amine, alkene, alkyne, and then halo, nitro or alkoxy groups. Clear? Now the point is, do you need to by heart learn this order? No, the answer is no. Why? Because you need not learn this order by heart, because as you practice, you will get a hang of it. You will get a hold of it and you will easily remember the priority order. You will get an idea that carboxylic acid is at top, then aldehydes, ketones are somewhere in the middle, and alkenes, alkynes are at the bottom. Clear? So, more you practice the nomenclature and the better you get, the better hold you get on it. So, you need to practice more and more of this nomenclature and you will find it very easy and not confusing at all. Clear? Now, on this basis, let's take some examples. Now, this is a compound. Look at the compound very carefully. The compound has two functional groups. One is hydroxyl and what is this? This is ketonic group. This is ketonic group which can be written as, this can be written as C double bond O. This can be written as C double bond O. Clear? So we have two functional groups in this compound, hydroxyl group and the other one is ketonic group. Now, which group will we take as the primary functional group? In this table, you can see ketone comes above hydroxyl alcohol group. Therefore, ketonic group will be taken as the primary functional group. Clear? So, this will decide the secondary suffix which is -one. You know, the secondary suffix of a ketone is -one. Ketone, -one of ketone. Clear? Now let's number the compound. You already know we will number the compound in such a way that the primary functional group gets the lowest number. Clear? So let's count it from this side 1, 2, 3, 4, 5, 6 and 7. Clear? So now when this is taken as the primary functional group, this hydroxyl group will become the prefix. It will be taken as a prefix. Hydroxyl group is written as a prefix as hydroxy. Always remember, the position is 7. The name of the compound will become 7-hydroxy. Wait a minute. 7-hydroxy. There are 7 carbon atoms. Therefore, heptane. Heptane, I am not writing the E because this is not an alkane. It is an ketone. So, heptane position 2 on. This is basically heptanone. So, heptanone mein E nahi aata. E doesn't come in heptanone word. Right? So the final name of the compound becomes 7-hydroxyheptane-2-one. Are you getting this? We have named this compound as per the rules we just discussed. Clear? This is clear to everyone? Okay, so let's take some more examples. I'm not rubbing this table for a while. Now in this above example, we have a double bond and a bromo functional group, both in the same carbon chain. Now the priority is given on this basis to the alkene, to the double bond. So how will you number the compound? You will number the compound in such a way that the double bond gets the lowest number. Clear? So let's number it like this: 1, 2 and 3. Longest chain is of 3 carbon atoms. So this is how this group is taken as the substituent group, which is written as a prefix as bromo. So you will write the name 3-bromo, 3-bromo, prop. Prop is your root word, prop 1-ene. 3-bromo prop 1-ene or 3-bromo-propene. Am I right? Am I right? Yes. This is how the name of the compound is written: 3-bromo-propene or prop 1-ene, and the reason you already know. Clear? Now let's take this example that we discussed earlier. I have already told you all that this is hydroxyl group. Some of you will get confused as to this is a hydroxyl group and this is a ketonic group. No. COOH is carboxylic acid group. Carboxylic acid group is also written like this. Similar form, right? So again you know that in this compound carboxylic group is on the top of the priority order. Clear? So this will be treated as an acid. Clear? So the numbering will be done in such a way that the carboxylic acid group gets the lowest number. Clear? So let's number the compound as 1, 2, 3 and 4. Now what will be the name of this compound? Since we have 4 carbon atoms, the root word will be bute. Bute. Carbon bond is at, double bond is at second position. Bute 2-ene 1-oic acid. The carboxylic acid is at 1 position. So the name of this compound becomes bute 2-ene 1-oic acid. Is this clear? 4 carbon atoms, bute, double bond at 2 position, second carbon atom, carboxylic group at 1 position. Hence the name bute 2-ene 1-oic acid. So you can now make out how easy is this. Once you get hold of all the rules, once you practice, you just get a hang of all these rules and it becomes very easy. Clear? Let's take some more examples. Suppose this is a compound. Suppose a compound contains more than 1 functional groups of same type. This compound has 3 alcoholic groups. In this case, you will indicate this by writing a prefix di or tri. This we have earlier discussed. Remember, when we used to have more than 1 double bonds, we used to use diene, triene. Similarly, when same type of functional group is there more than once, then di and tri prefix is added. Clear? So now What will be the name of this compound? 1, 2. This is 1. Now let's number this compound as 1, 2, 3, 4. In this case, the alcoholic group is coming at what position? 1, 2 and 4. The sum becomes 7. We will use sum rule over here. Suppose we number it the other way round, 1, 2, 3, 4. Now the sum becomes, what is the sum now? It is again 1. Now it is 1, 3, 4. The total is 8. So we always choose the lowest number, which means we will use this order 1, 2, 3, 4, 1. Clear? 1, 2, 3, 4. So the number of the name of this alcohol will become as 1, 2, 3, 4. It is butane 1, 1, 2, 4 triol. This will be the final name. Butane 1, 2, 4 triol is the final name of this compound. Butane is, but is the root word because of 4 carbon atoms. 1, 2, 4 are the positions of alcoholic group triol. Tri is the prefix used because we have three hydroxyl groups. Ol is the secondary suffix because it is an alcohol. Secondary suffix of an alcohol is ol, right? So this is the final name of this compound. Let's take one more example. A little complex compound we will take. Now this compound contains two ketonic group, as you can see. C double bond O, C double bond O, two ketonic groups. Numbering, if you will begin from this side 1, 2, 3, 4, or from this side 1, 2, 3, 4, it's one and the same thing in this case. Clear? In this case, it is one and the same thing. Now the root word you will get is butane, 2, 3, 2, 3 dione. Butane comes from 4 carbon atoms. 2, 3 are the positions of ketonic group. Di is the prefix used for two groups and one is the suffix used for a ketone. Clear? So the name of this compound becomes butane 2,3-dione. Let's practice some more questions. CH3, CH2, C double bond O, CH, C double bond O, CH3. Now this is a compound. Again you have two ketonic groups. Numbering of the compound will be done from that side when as such, in such a way, the numbering will be done in such a way that the ketonic group gets the lowest number. So therefore the numbering will be done from this side 1, 2, 3, 4, 5 and 6. Now the name of this compound is hexane. Hexane, I am writing E. Hexane 2, 4. Hexane 2, 2,4-dione. Hexane 2,4-dione. Is this right? Yes, it is right. Hexane 2,4-dione. Hexane is the root word coming from 6 carbons. 2 and 4 is the position of ketonic group. Di is the prefix used for 2 ketonic groups. And one is the suffix, secondary suffix used for ketone. Right? Let's practice some more questions. Suppose this is a compound. Now this compound contains a functional group, a double bond, and methyl groups as substituents. Clear? Now in this compound, first of all we would identify the primary functional group. Here only one functional group is present, carboxylic group. Therefore, the secondary suffix will be decided from this oic acid. Right? The longest carbon chain, let's identify the longest carbon chain. Now we need to number this chain in such a way that carboxylic acid gets the lowest number, right? So let's number it like 1, 2, 3, 4, 5 and 6. So we have 6 carbon chain. So the root word will become hexane 4. Now there's a double bond also at 2 position. So name of this compound becomes 4,4-dimethyl 4,4-dimethyl hexane 1 oic acid. 4,4-dimethyl hexane 1 oic acid. Sorry, double bond. I forgot to tell you the double bond. The name will become 4,4-dimethyl hexane 2-ene 1 oic acid. This is the name of this compound. 4,4-dimethyl substituents. Position of substituents. Hexane because we have 6 carbon atoms. Double bond at 2 position 2-ene and oic acid carboxylic group at 1 position. So this is the final name of this compound. Is that clear? Let's take one more example. In this compound there is a triple bond and which group is this? Identify this group. This is CHO, aldehyde group. The functional group is aldehyde. Clear? So the final suffix will be al because it is an aldehyde. Numbering of carbon will be done in such a way that this carbon gets the lowest number 1, 2, 3, 4, 5 because the priority is given to aldehyde over triple bond alkyne. Clear? So now the compound's name will become, since there are 4 carbons, pent 4-ine. I will not write the E. Pent 4-ine dash 1 al. Pent 4-ine 1 al. Pent 5 carbon atom. 4 is the position of triple bond. Ine for triple bond. 1 is the position of aldehyde group. And al is the suffix of aldehyde. So final name is pent 4-ine 1 al. So easy. Just you need to know all the rules and regulations and it is very easy to name the compounds. Right? Let's take examples of some ethers. Now this is an ether An oxygen atom between two carbon atom is ether group, COC, like this. Clear? Now the name of this compound will be written as, the name of ethers are written as alkoxyalkene. Alkoxyalkene. So the name of this compound becomes methoxymethane, because on both sides we have only one carbon atom. One carbon. Methoxymethane. Here we have ethyl group C2H5 and C2H5. Am I right? Just take a look very carefully. This is C2H5, this is C2H5. Both sides there are ethyl groups present. So this compound will be known as ethoxyethane. Now, what will be the case if two different groups are present on both sides of O? Suppose here we have CH3 and here we have CH3CH2. Now the rule is that oxy goes with less number of carbon atoms, smaller alkyl group. Oxy goes with the smaller alkyl group. Therefore, this compound will become methoxy. This one is a smaller, no? One carbon. This will become methoxyethane. The name is methoxyethane. These are the IUPAC names of ethers. If we talk about the common names, the common name of this compound is dimethyl. Since we have two methyl groups, dimethyl ether. The name of this compound becomes diethyl ether. Diethyl ether. The name of this compound becomes ethyl methyl ether. The small will be written first. Methyl, ethyl, methyl, ethyl, ether. Clear? One more is left. Let's discuss about esters. The name of the esters are written as alkyl alkanoate, ethyl alkanoate. For example, CH3, C double bond O, OCH3. COO are esters. COO is ester group, always remember. You know already. COO is ester group. So the name of this compound will become what? Always remember the one besides O, oxygen, is taken as alkyl, and the other part, rest of the part is taken as alkanoate. How? This is written as methyl, and here the carbon atom 1 and 2 carbon atom. So methyl ethanoate. Similarly, suppose I am writing CH3, CH2, C double bond O, CH3. Now this will be written as, the name of this will be, the alkyl group besides oxygen atom is taken as alkyl and rest of the chain is written as alkanoate. Are you getting the point? So the name of this compound will become methyl 1,2 methyl ethanoate. Sorry, here also we have 1 and 2 carbon, 1, 2, 3 carbon. The name of this will become propanoate, methyl propanoate. Is this clear to everyone? This is how the name of an ester is written, as alkyl alkanoate. The group accompanying oxygen is taken as alkyl and rest of the chain is written as alkanoate. Clear? COO group is known as ester group. So that is all in this part of this. I hope you all you have understood all the concepts used in the IUPAC nomenclature. And as I always say, practice, practice, and more practice. The more you practice nomenclature, the more you will get a hang of it. Clear? And it will become very, very easy for you all. So that's all in today's class. See you all in the next class. Until then, goodbye. See you.